Today we just do examples 3 and 4. And what I want you to do is I want you to turn to your very back page. And on the back page, you have a list of formulas. This is the sheet that you will get on your test. So you can see that the laws of logarithms, which you'll probably have memorized anyways, those are there. And the two that we're going to talk about today, well, the three, the change of base formula, we'll get to that in a little bit. But the basic properties of logarithms, one thing you need to understand is that log base a of a to the x, that these are inverse operations. And sure enough, those cancel, leaving you with just x. Or if you had a to the log base a, those cancel and leave you with just x. So those inverse operations are what we want to focus on today in that property. So the idea is if we could change the base to match the base of the logarithm, then we can get things to cancel. And so in this example, it says to evaluate the following expressions. Right now, I do not have a base of 2, but we'll create a base of 2, and you'll see how. First of all, I'm going to rewrite this to be a log base 2 of 32 to what power? Yesterday, you learned one of the laws of logarithms was that we could take this 1/2 and do what with it? So we have 1/2 times the log base 2 of 32. So I have a base of 32 and a base of 2. I would like these to be both a base of 2. Can you rewrite 32 so that it has a base of 2? 2 to the 5th. So this becomes 1/2 times the log base 2 of 2 to the 5th. Notice that these are inverse operations of each other, and so they cancel. You're left with 1/2 times 5. 5/2. Yeah, it seems like magic. But if you look at this log base 2, that means a base of 2 to what power is equal to 2 to the 5th? Well, 2 to what power is equal to 2 to the 5th? 5. So you get 5, then times it 1/2. So it's not magic, it's not voodoo, but it seems a little bit different from what we've done. So it's not as intuitive. Okay, the next one, what base do I want to come up with? 5. Right now I have 100 and I have 4. Write it using division. 100 divided by 4. Which is? Can you write 25 as a base of 5? 5 to what power? So again, these are inverse operations of each other. They cancel. Next one, what can I do with 4? 4 times the log base 3 of, you write 27 as base of 3. Four times 3 is base. Class now. The logarithm is in the exponent as opposed to the other way around, right? I mean, it's switched. There's still inverse operations of each other. So I have a base of p. What is the base of natural law? Base of p. Just cancel. 15. Not exactly. Forget. If I had just 3 natural laws of 5, how can I go to that? log of 5 to the third. Great. So this becomes e to the natural log of 5 to the third power. Now I have my natural log of 7. So these are first operations. Go to the calculator. Plug it in. Second natural log is how you get this. But e to the 3 natural log of 5. So log base 3. Another way to write this is log base of 5. Natural log is that. The log Okay, our very last piece that we're going to do is we're going to then solve logarithms or evaluate logarithmic expressions that don't have a base that we're familiar with. So for example here, the log base 6 of 14, what that means is 6 to what power is equal to 14. If I told you to give me an accurate assessment of what that number is, you might really struggle. I mean, why don't I give you an estimate? 1.5. I think that's a really good guess. Let's try that. 6 to the 1.5. 6 to the 1.5. And we get 14.69, so it's probably decrease that. So 6 to the 1.4, and that's too small. How about 6 to the 1.8? Well, 1.48. 6 to the 1.48. 6 to the 1.48. 6 to the 1.47. Okay, so maybe 1.475. Getting tired of this? I agree. So what you could do is, in order to evaluate this, we change it to a base that we know. What are the two bases you have on your calculator that you know? 10 and E. So we can change the base. We can rewrite this as log base 10 of this number, 14, divided by log base 10 of this number, 6. You can change the base to whatever you want. So if I wanted to write it as natural log, which is a base of E of 14, divided by natural log with a base of E of 6, you're going to get the same answer. If you had a function on your calculator where you could do the log base pi of 14 over log base pi of 6, it's going to be the same. It doesn't matter. You change it to your liking. So I generally type in natural log. Sometimes people get angry. They're like, why don't you just press log? Well, because it's free country. Do what you want. So I'll type it in. And so we've got natural log or log, whatever you want, of 14 divided by natural log of 6. And make sure you close your parenthesis. And you can see you get 1.47288,594. So I'll write down 1.47 And if you wanted to check it, you could, take 6 to the 1.47. But as you can see, you don't come up with 14. So generally speaking, when you're working with logarithmic or exponential functions, you found 6 decimal places. Okay, now, you don't have to do that on your assignment today, but if you do ever want to check your answer, you type 6 to the 1.47288 6. So, that's the very simple algebra. Right? You tell me the two integers, that's 0 and 1. So, how would I rewrite this? Log of, log of, and you don't even have to write the base 10 on there. Just do log 2 by log of 7. We can do 0 and 1. Yeah, 3, 2.81. That's all you're learning today. Next time, you got a lot to do. 35 minutes. This was your assignment yesterday, Monday. This is your assignment today, Tuesday. If you'd like to just put them all together into one, that's fine. If you finished yesterday's, you want to start a new one, that's fine. It's entirely up to you. So I'll stop the video and I'll come around and